Imagine you're building an AI to detect rare diseases. But here's the problem, the data. It's all about healthy patients. There are 100 healthy cases for every one sick patient. This is what we call class imbalance, and it's a silent killer of machine learning models. But it's not just about missing data. Real-world datasets are messy. Classes overlap, like red and blue circles tangled together. And there's noise, weird, random points that don't belong anywhere. These three issues, imbalance, overlap, and noise, are like a perfect storm that ruins model performance. And here's the kicker. Most AI tools were built for binary problems like is this email spam or not, but real life. It's multi-class. Is this tumor type A, B, or C? Is this network attack a DDoS, phishing, or malware? The rules change and most tools fail. So how do we fix this? Enter IMOVNO+, a new AI framework that tackles imbalance, overlap, and noise at the same time, for both simple and complex classification tasks. Let's break it down step by step. Step 1, understanding what's really important. Most tools just look at how many samples there are. But IMOVNO+ asks, how confident is each data point in its own class? It uses conditional probability, a statistical measure that quantifies how likely a sample is to belong to its assigned class, given its features and neighborhood. Think of it as a confidence score for every point. Based on this confidence, the dataset gets split into 3 zones. Core region, high-confidence samples, solid, trustworthy data. Keep these. Overlapping region, uncertain samples caught in the gray area between classes. These are ambiguous and dangerous for training. Noisy region, low confidence, outlier-like points, statistically unlikely to belong to any class. Remove them. This way, we don't accidentally trash important, but rare data just because it's far from the crowd. We preserve meaningful minority instances, not just their quantity but their quality. Step 2, cleaning the overlap, the big jump trick. Overlapping samples are dangerous, they confuse the model. So how do we find them? IMOVNO+ uses a clever combo, z-score plus big jump distance. Think of it like this, imagine you're walking through a forest. Most trees are close together, but then suddenly you step into an open field. That's the big jump. IMOVNO+ finds that jump and says, everything before the jump is overlapping. That's safe. But how do we detect the jump automatically? Enter z-score normalization. By standardizing distances from the core, we can identify statistically significant breaks, a jump that's more than 2 or 3 standard deviations from the mean. This makes the threshold data-driven, not arbitrary. No more fiddling with radius parameters or guesswork. The algorithm detects the natural boundary between clean and ambiguous regions, with mathematical rigor. Step 3, smart oversampling, no more fake overlaps. Now the minority class is still too small. So we generate new samples, but here's the catch, don't make the problem worse. Traditional methods like SMOT just interpolate between points, but that can create new overlaps. Imagine creating a synthetic point right in the middle of 2 classes. Now the model sees a fake boundary where none should exist. IMOVNO+ fixes this with multi-regularization penalties. It says, make the new samples close to their own class, but far from others. Specifically, it adds penalty terms to the generation process. A proximity penalty to keep synthetic points near their original neighbors. A separability penalty to push them away from the decision boundaries of other classes. This isn't random interpolation, it's constrained generation. The model learns not just where to place new points, but how to place them so they reinforce the class structure, not distort it. The result? A tighter, clearer class boundary. No more messy overlaps. The synthetic data doesn't just exist, it enhances the model's ability to generalize. Step 4, smarter ensemble learning, pruning the weak. Even with clean data, models can fail if they use too many weak classifiers, like a team full of average players. So IMOVNO+ uses a meta-heuristic algorithm called JAIA, a population-based optimizer that doesn't rely on gradients. It works by iteratively improving candidate solutions through trial and error, guided by the best-performing ones. It analyzes each classifier's contribution, not just accuracy, but stability, diversity, and error patterns. Then it prunes the ensemble, removing those that are redundant, inconsistent, or overfit. The result? A leaner, faster, more accurate model. Reduced complexity. Better generalization. And no more bag of weak models, dragging down performance. It's like hiring a coach who fires the underperformers, leaving only the stars. White heavy checkmark the results. Mind-blowing. On multi-class datasets, IMOVNO+ improved performance by 37% to 57% in G-mean, 25% to 44% in F1 score, and up to 42% in recall, meaning it finds way more real cases. In binary tasks, it reached near-perfect results, with gains of 13% to 39% over other methods. But what makes this truly impressive? The experiments weren't cherry-picked. Researchers tested IMOVNO+ on 35 real-world datasets, from medical records and vehicle classification to industrial fault detection, using 5-fold cross-validation. And across all of them, IMOVNO+ consistently outperformed state-of-the-art methods, not just on average, but on every metric, every run. Even more telling, The Nemini test, the gold standard for statistical comparison of machine learning algorithms, confirmed that IMOVNO Plus is significantly better than all but one competitor. It's not just good, it's statistically superior. Direct hit why this matters. This isn't just academic. This framework helps doctors detect rare diseases earlier, catching cancers or genetic disorders before symptoms appear. Cybersecurity systems identify zero-day attacks, even when they don't match any known pattern. Factories predict equipment failures before they happen, minimizing downtime and risk. It's especially powerful in real-world scenarios where data is scarce, like medical records with privacy limits or rare industrial faults. When every sample counts, IMOVNO Plus ensures that the model learns from the right data, not just the most data. Clapperboard final thought. Class imbalance, overlap, and noise aren't just technical problems, they're real barriers to better AI. But with IMOVNO Plus, we're not just fixing data, we're rethinking how AI learns from messy, real-world chaos. It's smarter data cleaning, smarter learning, and a smarter future. So next time you see an AI making a life or death decision, you'll know. Behind the scenes, frameworks like IMOVNO Plus are making sure it gets it right.